Right. Assalamualaikum warahmatullahi wabarakatuh. Good day to the lecturer and my fellow friends. So today I'm going to start. We're going to start about our presentation, which is the group project assignment. Right. So let's start the presentation.
Okay, for introduction, we, we can know that suspension system is an mechanical unit on the most vehicle in the automotive industry. Okay, suspension create momentum and steering force are essential to driver safety. To those only focused with ride comfort, the suspension system may appear to be little more than a series of spring and shock absorber. Its permit relative movement between the wheel and vehicle body, include in the section of the ride and vehicle extension generated by road surface. Tire contact patch will sustain rolling motion through the pitch when experience the response through logical and lateral force during braking, acceleration, and cornering.
Assalamualaikum warahmatullahi wabarakatuh. My name is AZHARI bin Nazari. So for this slide, I will tell you about article review. So for the first article review is about design of constant robust controller for active suspension in wheel driver electric vehicle. In this article, the author present a restricted robust H infinity controller design for an active suspension system for in-wheel independent driver electric vehicle with consideration given to both control, constraint and parameter variation. So for the next article is about model free fractional order sliding modular control for an active vehicle suspension system. In this research, researcher introduced an extended state observer based model free fractional order sliding modular control for active suspension system in passenger vehicle while keeping the dynamic wheel load and the suspension inflation with safety intentional limit improving ride comfort in the is the primary focus. So this is for me and from this slide. So we go for the next slide.
Okay, for the article review, okay, we choose for the article is about research on safety of intelligent vibration control system for electric vehicle suspension. In this research, an integrated design scheme of electric vehicle suspension based on wheel vibration damping system is proposed to serve electric vehicles pure vertical vibration performance. This seems control system use fuzziness between vehicle suspension and in wheel vibration damping system. The objective of this research is to address the issue of pure vertical vibration performance in electrical vehicles. Next, the LRQ technique based on particle swarm optimization weight coefficient is used in this research methodology along with a LQR controller and a MATLAB simulation experiment to confirm the result. The research result indicate that the in-wheel vibration dampening system based on electric wheel provides obvious advantage over the standard electric wheel system in terms of body acceleration, relative dynamic load of the wheel and impact force of the motor. Since the integrated design scheme of an electric vehicle suspension based on e-wheel vibration damping and the LQR optimization controller is new, the author of this study needs to do more research to ensure the findings and the data are accurate. This research attracted me because the LQR optimization controller regulates the electric in wheel vibration dampening system to improve vehicle ride comfort and electric wheel vibration performance. The next article is about a semi-active vehicle suspension control strategy based on negative stiffness characteristic. In this research, the author proposed a semi-active vehicle suspension model with negative stiffness and analyzed the effect of negative stiffness characteristic upon vehicle response. The objective of this research are to determine whether a vehicle suspension with negative stiffness is practical, examine the impact of the negative stiffness on the smoothness and stability of the suspension. The methodology used in the research is the author builds a quarter vehicle suspension model, simulates the model on different levels of road excitation using MATLAB. The result of the research is the semi-active vehicle suspension with negative stiffness characteristics can significantly reduce vehicle vibration in the low frequency phase, as well as increase vehicle comfort and stability. My journal only includes research categories for general review, but this particular research interested me because of a revolutionary technology that aims to improve vehicle comfort and stability by reducing vibration and tire deflection. The author design for a stiff car suspension mechanism can be improved and studied further to achieve far better result for reducing vehicle vibration. Okay, that's all for me.
Okay, Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Safiq Andrian Bmma ISAK. I will continue at the task B. So first, the first car is Produa Azia. So Produa Azia use McPherson on the front suspension because it's very suitable for the front wheel drive. For the rear suspension, use torsion beam because it's very light and foldable according to the size and the weight of the car. So the tire size used on the car is 175, 65, radius 14. So Proto Asia is a hatchback car that usually has 14 inches size rims that can save the fuel because suitable for diesel with 850 cc to 1300 cc engines. So next, Proton Satra Neo. The front suspension Satra Neo use McPherson suspension because it's front wheel drive car. For the rear suspension, process Neo use a multi-link suspension that allows free wheel to combine both ride quality and handling. The tire size used on the Proto Satria Neo car is 205 45 16 inches for more traction on the road surface, and it's suitable for riding roads. This because Proton Saturnio is a Malaysian sport car that have 1600 cc and 140 horsepower. So the last car is Subaru WRX. So the McPherson, so the front suspension use McPherson suspension that's suitable for front wheel drive vehicle, but the Subaru use all wheel drive where it's turn for front and rear wheel simulate continuously. Uh, the rear suspension used by the Subaru WRX is a double wishbone, which is very suitable for use on segment C and segment D and all-wheel drive car because the double wishbone allows for great control over the center of chamber, chester, and roll. The tire size used on the Subaru WRX is 235, 45, 17 inches. So Subaru WRX use an engine with capacity 2500 cc where it's able to rotate the size of the wheel on all-wheel drive. The Subaru WRX use wider tire to produce better traction. So that's all my uh, task. Okay, I will give to my friend Sonex.
Alright. Alright. For the task discussion and proposal. Okay, my name is Mohamad Nabil, and I'm going to start. Alright. So after considering a few alternatives to a more advanced suspension system, we have decided to propose a semi-active suspension system that will improve our case study and will give more impact on vehicles manufacturing. So, as opposed with passive suspension system that works to satisfy the conflicting criteria of riding comfort and vehicle handling, active suspension system works by attempting to overcome those conflicts and achieve a result that will yield the best performance of the vehicle console while maintaining reasonable level of comfort. Okay, so the semi-active suspension system. So we have selected the continuous damping control system. So CDC or continuous damping control is a semi-active suspension system that adapts the vehicle damping in accordance to the driving situations and road conditions. The systems will continuously monitor and will movements and immediately adjust the damping of the every shock absorber. So the components of the CDC is comprised of three primary components, which is the sensors at each wheel that detect relative wheel to body position sensors, a dedicated control unit with integrated sensors that detect heavy pitch and body roll motion, and the active dampers, which electronically controlled valves that are individually controlled every 2 milliseconds in a continuous range between the softest and firmest damping. Okay, so next. See, okay. So the example of CDC application in the Opel or Vauxhall Astra. So this is the example of the CDC system that is installed in a vehicle today. So the CDC system in the new Astra comprised of 4 hydraulic shock absorbers that continuously adapt to the vehicle condition, the road surface, and the driving style. The aim is to keep the car sport disabled by permanently minimizing its rolling, dipping, or vertical movements. A network of sensors, including three body and two-wheel acceleration sensors, deliver all the information required for the best possible damping to the electronic control unit. Okay, so as we can see on this picture here, so there are several parts in which the CDC components, which is the CDC control valves, the CDC control unit, and the CDC control valves again. Okay, so the body switch is the mode where we will determine whether we want to prioritize comfort or prioritize performance. Okay, so next. Okay, so the advantage of continuous dampening control system is that it has greater safety thanks to optimized wheel damping. It enhances driving comfort and say, okay. So the example of CDC application in the Opel or Vauxhall Astra. So this is the example of the CDC system that is installed in a vehicle today. So the CDC system in the new Astra comprised of 4 hydraulic shock absorbers that continuously adapt to the vehicle condition, the road surface, and the driving style. The aim is to keep the car sport disabled by permanently minimizing its rolling, dipping, or vertical movements. A network of sensors, including three body and two-wheel acceleration sensors, deliver all the information required for the best possible damping to the electronic control unit. Okay, so as we can see on this picture here, so there are several parts in which the CDC components, which is the CDC control valves, the CDC control unit, and the CDC control valves again. Okay, so the body switch is the mode where we will determine whether we want to prioritize comfort or prioritize performance. Okay, so next. Okay, so the advantage of continuous dampening control system is that it has greater safety thanks to optimized wheel damping. It enhances driving comfort and dynamics, especially during lane change. It has precise tracking during acceleration. It has superior handling. It improves cornering stability. It has shorter braking distance thanks to better road contact. And it also continuously adjusts in real time. Okay, so next. Okay, that's all from me. Okay, I'm going to pass to the next group member. Okay, so thank you.
iteration of the system to improve ride comfort and driving experience. Okay, thank you.